Assalamu alaikum wa rahmatullahi wa barakatuhu, and a very good morning to all of my dear students. Today's topic is single movable pulley. Single movable pulley. A pulley whose axis of rotation is not fixed, means whose axis of rotation is movable, which is not fixed. Okay. In the single fixed pulley, the axis of rotation, this one is the axis of rotation, was fixed. But in single movable pulley, the axis of rotation is not fixed. It means that when we apply a force or effort, then the axis of rotation will move. Okay? So this pulley is a movable pulley. And single, so one pulley is, one pulley is used. That's why it's a single movable pulley. Okay, now look at the figure. In figure here, this is a load, this is a total pulley, okay, and this one is a string or a rope. Now this load is denoted by L. Okay, this load is, so which force acts on this string? I said earlier in the first video that in any rope or string or wire, when stretched, then a tension force acts on the rod. Tension force acts on the rod. Now here also there is a rope. If you apply a force or effort, then a tension force acts. Now look at this. This load is balanced by this tension and this tension. Okay, by this tension. So load is balanced by two tension 1, tension 2. So load is equal to or balanced by two tension, and if we apply force or effort here, then what happen? The tension here, one tension is also acts. So effort is balanced by this tension at that point, and this load is balanced by two tension. Okay, so L equal to 2T, that this one and this one. This load is balanced by two tension here, look at this, and effort is balanced by single tension. Now what is the mechanical advantage of a single movable pulley? We know the formula for the mechanical advantage is load by effort. Load by effort. Now here L equal to load equal to 2T, just put the value 2T, and effort equal to T. So this T and T will cancel, we get the value 2. So the mechanical advantage of a single movable pulley is 2. It has no unit. Why? Because this tension, this is a force, this is a force. Unit of force is Newton, unit of force is Newton. So Newton cancel, that's why it is the ratio of the similar quantity. Okay, mechanical advantage has no unit. I explained this in a previous video, that the first video of a machine. Okay, now mechanical advantage is greater than 1. Here look at this, mechanical advantage is 2, which is greater than 1, so it acts as a force multiplier. Okay, if the mechanical advantage is ideal, okay, then this pulley acts. This pulley, the efficiency of the pulley will be 100%. Okay, this mechanical advantage is equal to 2. The single movable pulley mechanical advantage is 2. This is the ideal condition. At ideal condition, the mechanical advantage will be 2. And what are the ideal condition? The efficiency will be 100%. And what is the condition for the ideal case? This rope has massless, which is practically impossible. This pulley has massless, which is practically impossible, and the friction between the rope and the pulley will be 0, which is practically impossible. But when this rope and pulley and there is no friction, then mechanical advantage will be 2. Okay, otherwise it is less than 1. Okay, but this is not the practical mechanical advantage. This is the ideal condition. Okay, ideal machine, single movable pulley. Okay, now Now here, look at this. What are the velocity ratio? We know the formula for the velocity ratio equal to velocity by effort equal to velocity by load. Just go for the previous video for the velocity ratio. Okay, velocity by effort, velocity by load, I have explained earlier. Okay, and we know that this formula is also for velocity ratio is distance moved by the effort equal to by distance moved by the load. Okay, if so, distance moved by effort will be 2x and distance moved by load is x. So the velocity ratio will be 2. Velocity ratio will be 2. Now look at this. Load is equal to 2t and effort equal to t. Okay, that is 2 tension. Then if we combine these two, we get E equal to L by T, means effort equal to L by T. Okay, effort equal to L by T. What is the meaning of this? Effort equal to L by T, it means that with 10 Newton force effort we can lift 20 Newton force load. Okay, with E equal to L by T means with 10 Newton force we can lift 20 Newton load. It means that with a smaller effort we can lift a bigger or heavier load. Okay, this E equal to L by 2 indicates. Okay, now come here, velocity ratio. Now velocity means distance moved by the effort. If we apply effort here, then what happens? This rope will move. Okay, in 1 second this rope will move in 1 second, and here this load, and in here two rope will be moved. Okay, now look at this. Don't go for the calculation. VR equal to 2. VR equal to 2. Okay, now VR, when we make a machine, when we make any machine, the velocity ratio of that machine will be fixed at the making, at the time of making. Okay, so the VR equal to 2. Okay, now this is a fixed value for a single movable pulley. Okay, VR is always fixed. Which, if the question will come that which quantity will be fixed, mechanical advantage or velocity ratio, then the answer will be the velocity ratio. Okay, velocity ratio, this case has been discussed in the previous video. Please go for the previous video. Okay, otherwise this will be so confusing. Okay, now look at what are the ideal condition. For ideal condition, what I said, mechanical advantage equal to 2, efficiency will be 100%. Efficiency means the input and output will be same. Whatever the amount of input, the output, if the same amount of output will come, then that machine will be the 100% efficiency rate. Okay, and here for ideal single movable pulley, velocity ratio will be fixed. This is not changed, but this 2 will be changed. Okay, this is fixed for the single movable pulley. VR, the value of VR will be fixed. Now, what is the other condition in a practical machine? If efficiency is not equal to 100%, it means that if efficiency of a machine is less than 100%, okay, consider the efficiency of a machine is 80% and 60%, then what will be the mechanical advantage of a machine? Now we know the formula for the mechanical advantage, that is MA equal to eta into VR. Now here mechanical advantage of a machine is less than 100, it means 80%, then put the value eta equal to 80 by 100, and VR, the value of VR is fixed, so 80 by 100 into 2, by calculating we get 1.6. Look at this, this is the less than 2. Mechanical advantage of a single movable pulley in ideal case is 2. but in practical machine whose efficiency is 80% or 90%, it always less than 2. So here if the efficiency of a machine is 80%, then mechanical advantage of a machine will be less than 2, 1.6. Okay. Now if the efficiency of a machine is 60%, then mechanical advantage will be 60 by 100 and 2. Look at this. This 2 will never be changed of a single movable pulley. This is a fix. Okay. Now for 60% efficiency, we get the mechanical advantage 1.2, which is also less than 2. So this is greater than 1. So if the mechanical advantage is greater than 1, it is used as a force multiplier. It is used as a behaves like a force multiplier. Force multiplier means with a smaller force we can lift a bigger or heavier load. Okay, so this is all about the single movable pulley. Hope you have understood.